is lesson 3-7, percent of change. There are some important vocabulary words for this chapter, or this lesson, so let's go through those first. Percent is the ratio of a number to 100. If you get a 93%, that means you have 93 out of 100 points earned, or something of that nature. Percent of change is the ratio of the amount of change to the original amount, expressed as a percent. I'll explain how to do problems like that in just a moment. Percent of increase is when a value increases from its original amount, while percent of decrease is when a value decreases from its original amount. Greatest possible error is 1/2 the measuring unit for any measurement. For example, if your measuring unit is in feet, the greatest possible error would be 1/2 of a foot, 0.5 feet. And we'll also go through some of those problems in a bit more details a little bit later. Let's look at a few things about percent. To understand percentages, we have to go through the basics of percentages, things that you should have learned when you were younger about how to change a percent to a decimal percent, fractions to percents, etc. Here we go. To change a percent to a decimal, you're going to move the decimal point 2 places to the left and omit your percent sign. So if I have 41%, I will move my decimal point 2 places to the left. And remember, if a number does not have a decimal point expressed in it, that decimal point is always at the end of the number. So 41%, the decimal point would be here after the 1. You move it 2 places to the left, it becomes 0.41. 2%, your decimal point would be after the 2. You move it 2 places to the left, add a 0 at the beginning, and your decimal would be 0.02. 150%, decimals again at the end. You move it 2 places to the left, and it becomes 1.5. 0.5%, you have a decimal expressed right here. You move it 2 places to the left, it becomes 0.005. To change a fraction to a percent, this is probably the hardest of the conversions that you have to do. To change a fraction to a percent, you're going to set your fraction up as a proportion equal to n over 100, or x over 100, or a variable over 100, and then solve the proportion. So 3/5 would be set up equal to n over 100. And then if you remember, you're going to cross multiply to solve this proportion. So you're going to have 5n equals 300. Divide by 5. Divide by 5. 5 goes into 36 times, so this would be 60 as a percent. To do your next problem, you again set it up as a proportion. 6 over 5 equals n over 100. Again, cross multiply. 5n equals 600. Divide by 5. Divide by 5. 600 divided by 5 is 120, so this would be 120%. Last one, 9/11. This one's a bit more difficult because it's not a nice, easy number. Equals n over 100. You will get 11n equals 900. When you divide by 11, you're going to get an ugly decimal. We've talked about how you can't leave things in decimal form. So I'm going to change this to a mixed number. 11 goes into 981 times, with 9/11ths left over, so this would be 81 and 9/11ths%. Do not give it as a decimal unless specifically told to round to a specified decimal place. If they tell you round your answer to the nearest hundredth, then of course you could leave it as a decimal. Last but not least, to change a decimal to a percent, you're going to move your decimal point 2 places to the right and then add a percent sign. So 0.76, if I move that decimal 2 places to the right, it becomes 76%. 3.5, if I move that decimal point 2 places to the right, it becomes 350%. 0.007, if I move that decimal point 2 places to the right, that becomes 0.7%. Changing a decimal to a percent and a percent to a decimal, very easy. Changing a fraction to a percent is a bit more difficult. Now, to solve percent of change, you need to use a proportion. And the proportion you want to use is a specific proportion. We have a specific proportion that's set up to solve all percentage problems when you're dealing with percent of change. Okay, percent of change, you're going to do the following proportion. Okay, well, let's go back to this just a second. To solve problems involving percent, you can use a proportion or an equation. We'll do a few problem solving, then we'll do percent of change. If I have 15.5% of 60 is what number? I can either change this to an equation or I can change it into a proportion. I will show you how to do both of these because some of you are going to like a proportion better and some of you are going to like an equation better. So let's start off with this. I'm going to just change this to a percentage, an equation first. 15.5%, I'm going to change that to a decimal, so it's 0.155. Of means multiply, so times. 60 is 60, is means equal, and what number becomes my variable? So I now have 0.155 times 60 equals x. So I simply need to multiply 0.155 times 60, and I will get 9.3 equals x. For those of you who prefer a proportion to this same problem, remember it's is over of equals x over 100 95% of the time. Is over of equals percent over 100. The word that follows is normally on top. The word that follows of is normally on bottom and equals the percent over 100. So if we do that, whatever follows is becomes what number? That's my variable there. Whatever follows of is the one on the bottom, that's 60, equals my percent is 15.5 over 100. And I solve this proportion. So I have 100x equals 15.5 times 60, which happens to be 930, divide by 100, and x is equal to 9.3. Same exact answer I got over here on the other one. It doesn't matter which way you use, whether it's an equation or a proportion, as long as you're familiar with one or the other, you can do either one. Second problem here, what is 20% of 90? I'm just going to use an equation here because it's fast and it's easy and I'm running out of space. So what becomes my variable is becomes my equal sign. 20% is a decimal is 0.2. Of means multiply, and 90 is 90. So I have x equals 0.2 times 90. So if I multiply 0.2 times 90, I get x is equal to 18. I can set up the proportion. I'm not going to solve the proportion, but set up the proportion. Okay. What is 20% of 90? What is 20%? 20 would go up here. Of 90, 90 goes over here, and the 100 goes over there. So is over of equals percent over 100. Number 3, the population decreased to 90% of last year's population. The population is now 270. What was it last year? Okay, simple question. You just need to be able to rephrase this into something that you can solve. We're looking for last year's population, so I'm going to let x equal the population last year. So it says the population decreased to 90% of last year's population. Okay, so 90% of last year's population. Well, last year's population is x, so 90% of that would be 0.9x, or 0.90x. And that population is now 270. So 90% of last year's population is now 270. We have the equation. All we need to do now is solve. So divide by 0.9, divide by 0.9. X will equal 300. And of course, it is a word problem, so we should write it in a complete sentence. So last year's population was 300. We're done. Percent of change problems. Now, a percent of change just simply means that I need to get it into a simple proportion. The percent of increase or decrease, it's either going to go up or it's going to go down. Your number is going to either go up or go down, and you'll know because you'll look at it and say, oh, gee, the number went up, or oh, gee, the number went down. To figure out your percent of increase or decrease, you're going to solve a simple proportion. You're going to find the amount of increase or decrease over the original amount and set that up as equal to a percent over 100. For example, the price of a skirt decreased from $32.95 to $28.95. Find the percent of decrease. If we're going to find the percentage of decrease for this particular problem, all we need to do is find how much it changed. We need to do that first. So basically, we're going to do 32.95 minus 28.95. That's the amount of decrease over the original amount. The original amount, it decreased from, so from, this is the original. So my original amount was 32.95. equals x over 100. So now I just need to simply do the math. If I do 32.95 minus 28.95, that's $4. So 4 over 32.95 equals x over 100. I'm going to solve this proportion. Okay, so I will have 4x. Oops, that was not right. I'm going to need to multiply across and then x. So I'm going to have 32.95x equals 400. Divide by 32.95. And then x will equal, if I take 400 and I divide it by 32.95, I'm going to get 12.1396, some really long decimal. Okay, 12.1396, the numbers. 95% of the time, they will tell you to round to a specified place value. I will always tell you to round to a specified place value. In this case, let's round to the nearest hundredth. So if we're going to round to the nearest hundredth, here's the hundredths place. If I look to the right, 9 is bigger than 5, so this would round to 12.14%. So the amount of decrease is 12.14. Number 2 here. Between 1940 and 1980, the federal budget increased from $9.5 billion to $725.3 billion. That's a very big increase. What was the percent of increase? Let's figure out how much increase it was. So you do the amount of change, so that's going to be 725.3 minus 9.5 over the original, which was 9.5, equals x over 100. So if we take 725.3 and subtract 9.5, you are going to get 715.8. So 715.8 over 9.5 equals x over 100. Cross multiply 9.5x equals 7158. Oops, 80. 71,580. 71,580. Take 71,580 divided by 9.5. And you will get x is equal to 753 over 0.7368. If I round that, okay, if I round that to the nearest hundredth, okay, right here, that would be 7,534.74%. That is a huge increase, 7,000% increase. But then again, that's a huge amount of money. We went from 9.5 billion to 725 billion. That's a huge change. So of course we would expect our percentage to be quite high. All right. The last time you measured something, you probably measured to the nearest something. Millimeter, centimeter, inch, foot, whatever. Because no measurement is exact, we have a percent of error when we measure. Okay? We as humans are measuring. We make mistakes. So there's got to be some sort of a percentage of error. The greatest possible error in a measurement is 1/2 of that measuring unit. So if you measure a picture for the yearbook and record its height as 9 centimeters, what is my greatest possible error? Okay? We measured to the nearest centimeter. So our greatest possible error is 1/2 of a centimeter. Not 1/2 of 9 centimeters, 1/2 of the measuring unit. The unit was centimeters, so 1/2 of it, so our greatest possible error, I like to abbreviate that as GPE, is equal to 0.5 centimeters, 1/2 of a centimeter. So we are off by, at the most, 1/2 centimeter. Okay? Let's say you read the bathroom scale as 122 pounds. What is your greatest possible error? And we're going to find the percentage of error. Okay, so we measure ourselves to the nearest pound. So our greatest possible error can be to the nearest 1/2 pound. Okay, the scale is off by 1/2 pound, one direction or the other. It's either too high or too low. To find our percent of error, right? To find our percent of error, we take the amount of error, the greatest possible error, that's this, Okay, greatest possible error over the measured error, the measured amount, and that equals x over 100. So our greatest possible error is half a pound. We measured it to 122 pounds, and that equals x over 100. So we solve this proportion. So we have 122x equals 50, because half of 100 is 50. Divide by 122. 50 divided by 122 gives us 0.4098. Okay, so x equals 0.4098. So approximately 0.4%. That's a fairly small error, less than half of 1%. Okay, fairly small error. Which means your scale is fairly accurate. All right, when a garden plot is measured, the dimensions were 156 inches by 84 inches. Use the greatest possible error to find the minimum and maximum possible areas. So now we're looking for minimum, maximum possible areas. Okay, we measured to the nearest inch, so our greatest possible error is a half an inch. Okay, which means our dimensions can change. The dimensions can be as small as 155.5 by 83.5, because we subtract a half an inch from each one of our original measurements. Or they can be as large as, if we add half an inch to each one of those measurements, 156.5 by 84.5. So this would be the smallest, and this would be the largest, because you subtract half of your greatest possible error from the dimensions, and then you add your greatest possible error to the dimensions. So our minimum area, the smallest area we would have, is going to be 155.5 times 83.5. Okay, 155.5 times 83.5. And that gives us 12,984.25. That's our minimum area. And of course, since it's an area, that's in square inches. Okay, so our minimum area is that. Our maximum area means we use our maximum dimensions, 156.5 times 84.5. 156.5 times 84.5 is 13,224.25. And again, it's an area, so that would be in square inches. That's our max area right here. So the greatest possible error tells us how do we get our maximum and our minimum area.